And now it gives me great pleasure to introduce Mr. Al DiLeonardo, AGS counselor and good friend, to introduce our keynote speaker. Al?
Okay, good afternoon, everyone. So the last time I got to do an intro was 2 years ago, and maybe some of you remember me, some of you don't from that. I literally split my pants about down the middle, about 18 inches prior to getting up here, within moments of getting up here, and it was ugly, to say the least. And because of that, they said, even though I'm an AGS counselor, they said, you can't come back and get on stage again last year. So before I introduce our speaker, I'll just say that thanks to Director Cardillo, he said, look, we're going to get you back up on stage this year, Al. One requirement is you need to wear stretchy pants. So I do have stretchy pants. Now that intro was not as funny as when I had the split pants up here. I guarantee you if you were here, you were laughing. And so that's the best I could do for an opening icebreaker for you. So I'm going to go ahead and introduce our speaker. It's my privilege to welcome back and introduce Mr. Robert Cardillo. He has supported this event in many different formats over the years, and we're glad to have him up here again. Robert is an accomplished intelligence officer, a leader of character, and a technology innovator. An accomplished intel officer, from starting out as an analyst at DIA, the Defense Intelligence Agency, to later running NGA, think NGA source that is, think data collection and gathering of geography data at NGA, to rising back to become deputy director at DIA. It could be said that much of his career was working across multiple agencies in support of mission analysis and geography. A leader of character. Later, as one of the deputy directors of national intelligence, he helped lead the day-to-day operations of the entire U.S. intelligence community, where he focused on bringing information intelligence sharing across the 16 intel agencies together. This was also a time when the nation conducted the bin Laden raid, and information sharing at that time, leading up to that event, was critical. At NGA, Robert is currently serving as the director of NGA. He has set a vision for the agency that focuses on the people while pushing the bounds of technology like machine learning, AI, data science, in order to modernize and advance his GeoInt mission. Again, GeoInt, geointelligence, think in some ways, many ways, geography. One example that Robert developed to validate the integration of technology was the Rapid Feedback Team, or RFT, a multidisciplinary data science team that set the standard for the intelligence community in how to create and evaluate tailored mission-focused data science tools. This was a powerful component of his larger GeoInt Services initiative to help bring GeoInt into the intelligence community cloud to better serve the larger intelligence community and DoD. An accomplished leader and change agent, Robert has reached out beyond the government into industry looking for good ideas to advance our national security and his GeoInt mission. No doubt, this is one of the reasons he is here today to share some insights with us on his agency's role in powering our future planet. Please welcome Director of NGA, Mr. Robert Cardillo.
Thanks, Al. I'll try to live up to part of that introduction. One thing I have learned over the years is to know your audience, know the context within which you're presenting. So I'm aware of the challenge I have in front of me here. I need to find a way to sustain the momentum of the invigorating and passionate and interesting discussions that you all have enjoyed and participated in. But I'm also aware that when I conclude, there is a break. There's some anxiety in the room. There's a little tension. When will he stop talking? On the upside, I'm guaranteed a standing ovation, right? So with that, thank you, Al, for that, and thanks to the American Geographical Society for inviting me back. We're told that as he looked at a map of Europe, that Napoleon had proclaimed that geography is destiny. Now, you may or may not agree with what he had in mind when he said that, but I think that you might agree, at the very least, that a firm understanding of geography is necessary to sketch the destiny of our future. It's what we've been hearing about this afternoon. It can define a nation state, a mega city, oil fields, uranium deposits, or a water source. By understanding all of the variables that bear on a particular part of the globe and how they're changing, you can gather significant insight into the future. And yes, how to craft and recraft that future. As the director of NGA, that's part of my job and probably each of yours as well. If you're not familiar with our agency, we are the premier provider of geospatial intelligence, think geography, to the United States government and our allies. Geospatial intelligence is a discipline that's focused on the exploitation and the analysis of geospatial data and information. We describe, we assess, and we visually depict physical features, natural and constructed, and geographically referenced activities on the Earth. Now, although our agency is relatively new by our current name, our mission set reflects a basic human desire to understand the physical space in which we live. One could argue that we may not be the oldest profession, but one could say that we certainly were important the first time one of our ancestors said, "That's my cave, and that's your cave. And this is the line upon which we'll agree that we're going to coexist." Our motto at NGA, know the Earth, show the way, and understand the world. In that context, we recognize the unique role that geospatial data plays to assess resources, monitor changes throughout our global environment. We're actively involved with safety of navigation, environmental hazards, food management, water security, as well as natural resource and land use. For example, we've led symposia on water, climate, food, combating wildlife trafficking, all to harness the advanced data collection and analytic methods of non-governmental organizations and academia to enhance what the federal government, including the intelligence community, can provide. As I speak, I have officers both in Springfield, Virginia and St. Louis, Missouri, who are supporting the combating of the fires in California. We're doing that through the National Interagency Fire Center of the Department of Interior. And that is common now for the employment of our service. But we also need to provide decision makers with the best data possible so they can make better decisions, better choices to enhance the sustainability and the security of our planet. And by sharing that information with first responders, military deployers, policymakers, we can understand the scope of an event much closer to real time. That's why we're moving more and more of our data and our services and our information to the World Wide Web. For us, foundational data is key to all of these efforts. It literally is the baseline to increase our predictive ability to automate the process, to maximize extent, to recognize indicators far enough in advance so that those we serve can act before, I say before, events dictate. We create, maintain, and share a variety of environmental data sets. For example, through predictive modeling, we can use snow cover to predict floods or famine, which in turn affects the ecosystem and the human geography. But we also know that we must improve our ability to anticipate and take action to prevent or respond in advance of potential disruptions to natural systems. For example, the next fire season. That's why NGA is so proud to join the State Department in sponsoring the Worldwide Human Geography Data Working Group. In June, I think some of you were able to attend the symposium the working group hosted with Georgetown University and the Urban Dynamics Institute at the Oak Ridge National Lab. The symposium brought together participants from 51 different organizations across the Department of Defense, civil agencies, academia, international partners, NGOs, and private corporations. Participants were able to identify a variety of human geography data sets that are instrumental to deepen our understanding of access to energy. At NGA, we know well the role human geography data plays to strengthen resilience and inform responses during and after energy disruptions and shocks. In other words, crowds are good, and because there is safety and security in numbers. We've been at the forefront to support first responders and decision makers with current imagery and data after disaster strike, whether it was Katrina in New Orleans or the current fires in California. As a result, we've grappled with the continued need for standardization in data collection, reporting, analysis across the field. We've created apps and tools for first responders to share data quickly and broadly, even in environments without significant wireless access. Those efforts are not enough. We need more creative approaches for data collection in data poor or signal poor environments, and I'm hoping that the people in this room can help us do that. And more than hoping, I'm counting on you. Now, I'd like to share a couple of examples of what we're accomplishing today, where GeoInt and NGA is heading, and how we can help meet some of the challenges we both face. I'm not going to start at the top, but rather at the bottom of the planet, the South Pole. Our agency recently provided the imagery, the expertise, and the experience necessary for the recent release of this map. It's the first reference elevation model of Antarctica. It's a terrain map of 98% of the contiguous continental landmass. It's a mosaic of data that was constructed from hundreds of thousands of individual stereoscopic digital elevation models. Those models were extracted from satellite images from our mission partner, Digital Globe. And because the data set was so large, we had to generate the model using the Blue Water supercomputer at the University of Illinois, Urbana-Champaign, one of the few computers available that's powerful enough to run the algorithm. Now, compared to the Arctic, which I'll speak about in a second, this project that we completed last year, this project was more straightforward. We didn't have border disputes to deal with. The elevation is quite flat, and unlike the Arctic, it's not split up between an ocean, several seas, large land masses, and many islands, all divided and disputed amongst different countries. Now, speaking of the Arctic, let's move from the bottom to the top. This is a digital elevation matrix, a high-resolution, high-quality one that analysts can use and do use to understand changes in topography over time. It's another example of public-private partnership, as it was also made by many of the same people, a team of scientists, geographers, cartographers, and analysts at NGA, at the National Science Foundation, the University of Minnesota's Polar Geospatial Center, and Esri. Now, this Arctic DEM has been used by government, academia, and commercial industry for analysis and production, to detect and quantify vegetation change and deforestation in places such as Siberia, to study ice cap collapse and loss, to study river systems, drivable roads, many of which had previously been inaccessible, and to measure the tsunami water height after an earthquake and landslide hit a village in Greenland. I had a French hydrologist come up to me after we released this data on the World Wide Web and talk about the refinements in his model because of the vast increase in the reference that he was able to use to provide better accurate predictions of future water runoff. And we can see, and we saw then, that when the world has open, high-resolution, satellite-based elevation data of places like the Arctic and Alaska, it can inform policy and decisions in an increasingly part of the world. And that information and that awareness is a good thing. Now, those are just two examples of how we're exploring the exploration of geospatial data we're seeing today. In addition to the polar elevation maps, we produce a number of other worldwide data sets, like the World Magnetic Model, the Earth Gravity Model, and the World Geodetic System 84. Taken together, these data sets can and are used to enable exploration, transportation, and monitoring of our energy resources, both present and future. These data sets and the maps generated from them are particularly important for those who travel on our oceans. Maritime transport remains the backbone of international trade and the global economy, particularly from an energy perspective. More than 70% of global trade is transported by sea and handled by ports around the world. Now, why would a gravity model or map make a difference to a sailor? Well, similar to the effect that the moon and the sun have on our tides, the gravitational force of uneven mass distribution across the Earth's surface and subsurface, mountains, valleys, heavier and lighter density, all of these things cause what's called permanent tides. These tides force water to pile up where gravity is higher and recede where gravity is lower, actually giving the oceans an irregular, bumpy surface. Now, measuring gravity everywhere allows us to model ocean levels in all locations and establish a mean sea level. And these models help us develop GeoInt for a variety of programs: safety of navigation, ballistic missile guidance, the global positioning system, as well as other mission areas within NGA and the National Geodetic Survey. The worldwide gravity compensation data supports navigation for U.S. military operations, mission planning, and safety of navigation with our collection platforms, whether they're in space, air, surface, or subsurface. It's part of the World Geodetic System 84, which is our reference system. It's an inclusive and complex model that defines our latitude, our longitude, and our ellipsoid height system. It reflects our dynamic physical Earth and takes into account geodynamic motions such as plate tectonics and the daily movement of the Earth. The inability of the world's tankers and others' fuel shipments to stay on track, even temporarily, would lead to substantial delays and higher shipping costs, resulting in higher worldwide energy prices. Inaccuracy in mapping ports, an unexpected obstacle at critical choke points like the Straits of Hormuz, could expose these tankers to the greater risk of theft from pirates, terrorist attacks, political unrest, or shipping accidents. So in a very real way, these maps keep the engine of global commerce running on track and on time. Our International Hydrography Office, along the same lines, is currently crowdsourcing to update the World Port Index, which gives sailors around the globe a more complete and robust source of information about global ports. We're also leading agency in another ocean crowdsourcing effort, the Seabed 2030 Bathymetric Initiative, which will reach out to commercial industry, academia, and government organizations to create a more complete database of worldwide bathymetry. In today's environment, data are instantly available, and NGA is working to be equally nimble in our response to it. For example, we've created the rapid feedback teams that Al mentioned to look at cases where we can quickly and agilely respond to customer needs using automation, augmentation, and artificial intelligence. As you know, we're seeing more data than we've ever had before, and now dealing with it and presenting with it, creating what I call coherence from chaos, is a critical need. We're doing all of this with you, with partners, with academia through open competition and hackathons online. And the RFTs have taught us a number of case studies to monitor and understand the ecological impacts of the evolving energy sector. For example, in Nigeria, we explored the repercussions of an oil monoculture, unabated development, and neglect of non-existent oversight that caused pollution and damage in the Niger River Delta. Additionally, the team used nighttime light measurement imagery to monitor the changing landscape of the energy sector, both in countries that have emerging or existing energy infrastructure. So as you can see, we're expanding our unclassified geography community in a variety of ways. And if you're not currently our partner, I'm inviting you to join us. To further improve our ability to anticipate and predict, NGA is engaged with innovation centers out in the Silicon Valley, in New York City, in Boston, St. Louis, and Austin, to work with industry using exploratory technology to identify and explore, and where appropriate, adapt the latest GIS technology and predictive analytics. The availability of data and advanced technology and tools are enabling a new breed of contributors who aren't necessarily GIS professionals. These non-traditional partnerships are the key to our future. That future is increasingly in an interconnected world, in large part on our ability to collect and share information, real information, so that we can help leaders at all levels make more informed decisions. Geography can still shape and does still shape the boundaries of our destiny. Geographic data, geographic technologies, and geographic understanding will be essential to navigating that collective future. Put another way, it's your passion, it's your profession that will lead to a brighter future. If we're connected today, I'm here to thank you. If we're not, I'm here to invite you to a partnership. And in either case, I thank you for this time and being part of this dialogue. Thanks very much.